For number 24, we want to find, given a coordinate point, on the terminal side, find the value of the trigonometric function indicated. So the coordinate point 3, -4 is to the right 3 and down 4. So I'm in the fourth quadrant. So I'm going to go to the right 3, down 4. The right 3, down 4. So I know side length can't be negative, but location is what's important as far as like the angle goes. And then 3, 4, this is a 3, 4, 5 triangle. So the question is, what is cosecant? Well, if cosecant is reciprocal of sine, and sine of theta is opposite over hypotenuse, then sine is -4 over 5. And that means cosecant of theta is the reciprocal, -5 over 4. You don't have to start with finding sine, but I like to. Number 25, cosine. And we're trying to find the cosine using the terminal side that goes to the point 12, 12. 12, 12 is in the first quadrant, so it's definitely a 45, 45, 90. And if you remember that, then you can say that this is 12 squared roots of 2. If you don't remember that, then you got to do a squared plus b squared equals c squared. And so what you end up with is 2 times 144, or 288 equals c squared. So c equals the square root of 288, which is 144 times 2, which is 12 square roots of 2. So I want cosine. Cosine of an angle is adjacent over hypotenuse. So cosine would be 12 over 12 root 2. The 12 simplify out. I'm going to rationalize though. And so my final answer is square root of 2 over 2, which shouldn't be surprising considering it is the 45, 45, 90 in the first quadrant. And cosine is square root of 2 over 2 there. Okay. Number 26. It says, if cosine of theta minus pi over 2 is 0.93, then find sine. Well, here's what I know. Cosine of pi over 2 minus theta is sine of theta. This right here is sine of theta because they're cofunction identities, which means sine of theta is 0.93. And there's my answer. Cofunction identities. Cosine of pi over 2 minus theta is equivalent to sine of theta. So the two non-right angles in a triangle, the sine and the cosine are the same. All right, number 27. If cosecant, and I had you guys change this to 8/3, -8/3. If cosecant is -8/3, find tangent. Now I will say I was a little bit, too vague on this one because technically you've got two different options. Kind of do, but oh well. Cosecant is -8/3. Okay. First off, I'm gonna deal with this. It says find tangent of pi over 2 minus theta. To me, that's just saying, hey, find cotangent, because tangent and cotangent are cofunctions. So this is what I'm going to be finding. I know cosecant is -8/3. That actually, there's two different ways to solve this. I know cosecant is reciprocal of sine, which means sine is -3/8. So here's what I know. I know sine is negative in the third and the fourth quadrant, so technically I don't know, am I here or am I there, right? So I could say sine is -3/8 or sine is -3/8, in which case I've got two different side lengths right here. I mean, they're the same, but one of them's negative, one of them's positive. So if I do the Pythagorean theorem right quick, a squared plus b squared equals c squared, so a squared plus 9 equals 64. Then 64 minus 9 is 55, so this is the negative square root of 55 on this side and the positive square root of 55 on that side. So if I wanted to find cotangent of this angle, cotangent is, if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So I would have to say the square root of 55 over -3, so I would float that to the top. Or it could be the negative square root of 55 over positive, or -3, which means square root of 55 over 3. That's one option. My other option is knowing my Pythagorean identities. I've got cosecant, so cosecant of theta equals -8/3, and I want to find cotangent, right? Well, that's a Pythagorean identity. I know that cotangent squared, or well, let's do 1 plus cotangent squared equals cosecant squared, right? So 1 plus cotangent squared equals -8/3 squared, which is 64/9. If I start solving for cotangent squared, I'm going to subtract 1. So if I subtract 1 over, then 1 is 9/9, and 64/9 minus 9/9 is 55/9. And then I take the square root of both sides. And when you take a square root, there's two answers. So I would get cotangent of theta equals plus and minus the square root of 55 over 3. And that's another way to get my answers. I think I would narrow down a little bit more, or not be so sneaky. But at the same time, I don't know. It's kind of a good little extension. Make sure you know what you're finding, or the potential. Number 28. Find cotangent and secant if cosecant is 3 and cotangent is less than 0. Okay, so this is one of those ones where I have to know what quadrant I'm in. If cosecant is 3 over 1, then that means sine is 1 over 3. Sine is your y value, and your y values are positive in the first and second quadrant, right? So I've got, in my bow tie, these two are out because I've got to have a positive sign. But then it says cotangent is negative. Nothing is negative in the first quadrant, so it has to be in the second. So in the second quadrant, I've got a triangle. This is not going to be to scale. And sine is 1/3, so sine is opposite over hypotenuse. And if that's 1 and that's 3, then this is a squared plus b squared equals 3 squared, or c squared. So then b squared equals 8, which means b equals 2 root 2. But since we're going left, that needs to be negative 2 root 2. Because the square root of 8 is 4 times 2. So square root of 4 times 2. So I'm asked to find cotangent of theta. Cotangent is the reciprocal of tangent. If tangent of theta is opposite over adjacent, then cotangent is adjacent over opposite. So negative 2 root 2 over 1. And then also find secant of theta. Secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent, which I want us to rationalize. So I'm going to multiply top and bottom by the square root of 2. And I'm left with negative 3 square roots of 2 over, this is it, that doesn't cancel out, it just becomes a 2. So over 4. So the cotangent is negative square root of 2 over, or negative 2 square roots of 2. And secant is negative 3 square roots of 2 divided by 4. Number 29. It says, find cosine and tangent if secant is 7/3. So that means if cosine is 3/7. In my bow tie, I know that cosine is positive. Cosine is adjacent. It's the x value on the right-hand side because my x values are positive here. My x values are negative here, so that's out. And then it says sine is positive. Well, sine is my y value, so I'm positive here, negative down there, so I have to be in the first quadrant. So I have a triangle in my first quadrant. And I know that I've got adjacent is 3 and hypotenuse is 7. So I'm going to do Pythagorean theorem. A squared plus b squared equals c squared. So b squared equals 49 minus 9, which is 40, which means b equals the square root of 40, and the square root of 40 is 4 times 10, which is 2 root 10. So this right here is 2 root 10. The goal was for us to find cosine and tangent, right? So cosine of theta equals adjacent over hypotenuse, so 3 over 7. No, we already know that one. And then tangent of theta is opposite over adjacent, so 2 square roots of 10 over 3. And there we go. Number 30. Find cosecant and cosine if tangent is negative 5/4 and cosecant is positive. So tangent is negative. Let's talk about the bow tie. Positive, positive, right up, right down, left up, left down. Tangent is opposite over adjacent, so positive over positive, that's out. It's got to be negative. Positive over negative, that's in. Negative over negative, that's positive. And then negative over positive, that's in. But cosecant has to be positive. Cosecant is the reciprocal of sine, which means sine has to be positive. Sine's the y value, and the y value is not positive down there, so it must be in that quadrant. So I have a triangle in the second quadrant where tangent is -5/4. So I'm just going to ignore the negative for a second and think opposite over adjacent. Opposite over adjacent, and then one of them gets the negative, and it has to be the 4. So Pythagorean theorem, 16 plus 25 equals c squared. So that is 41. So this is the square root of 41. The question is, what is cosecant? Cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So square root of 41, sorry, I guess you didn't see my Pythagorean, over 5. And then cosine is adjacent over hypotenuse. So adjacent over hypotenuse, -4 over the square root of 41, or -4 root 41 over 41 if you rationalize. Last one on this page. If cosine is negative, cosine is the x, so if x is negative, then that means we're going left, not right. So cosine's got to be negative, and it says tangent is positive. Well, tangent is opposite over adjacent. So plus over minus is minus, but I need it to be positive because it says greater than 0. So negative divided by negative is positive. So we are in the third quadrant. Cosine is adjacent over hypotenuse. So I'm going to put adjacent 1, hypotenuse 3. One of them gets a negative. Hypotenuse can never be negative, so it's -1. And then Pythagorean, 9 minus 1 is 8. So this is 2 root 2, the square root of 8. And then the question is, what is sine? So sine is opposite over hypotenuse. So -2 root 2 over 3. And then what is cosecant? Cosecant is the reciprocal of sine. And so that would be -3 over 2 root 2. But I'm going to multiply top and bottom by the square root of 2. Those numbers are the same as that up there. Rude. Okay. So -3 square root of 2 over 4. Well, some of them are. And there we go.